Now try this one yourself. This one is y squared, x is not squared. So if x is not squared, you want to change the form into the standard form. What was the standard form? The variable is not squared should always stand alone. That means you want to do is both sides divided by -5. Then you cancel -5, +5. So then you have a x stands alone. Okay. So you then have x equals 3 over -5, 3 over -5. Okay. And then x stands alone. This equals 3 over -5 times y squared. Okay. And then from here, the standard form is always numerator is 1. So you got to move 3 down to the denominator in this way. Okay. Then this guy has to be equal to 4p. And you got to compare with this one. This is x equals 1 over 4p y squared. Okay. The difference is here is negative, but that's not the problem. If it's negative, the open direction is to the left. So anyway, 5 over 3 has to be equal to 4p. Okay? Okay, then you set up an equation. 4p equals 5 over 3. You then got to solve for p. To solve p, both sides multiplied by 4. So p equals 5 over 12. Because 3 times 4 is 12. And 1 times 5 is 5. So you then have a p now. Okay. So, now, if you have a p, the focal points, the vertex in this case is always on the origin. It doesn't matter the open direction is to the right or to the left. So in this case, the vertex is easy to tell is 0, 0. Okay. But the focus in this case is different now because here there is a negative. If there is a negative, the open direction will be to the left. Then the focus should also be to the left. Directrix it should be on the right. We have a p is this value 5 over 12. So you only need to do is switch this point to the left. And then that will be -5 to the 12. Then you have a 0. So you then have a -5 over 12, 0. And directrix has to be on the right. Okay. And the directrix will have x equals +p for this case. So x equals 5 over 12. Okay. Those two are different. Here y without squared, so the open direction is vertical. Here is the x without squared, so the open direction is horizontal. And the negative tells you is on the left. Right here. Open direction is to the left. Okay. Those two are typical examples. Now, this first two example basically gives us from the algebraic equation, we can tell the geometric features where the vertex and the focal points are and where the directrix is. We got to do more on that. Okay. Look at this example. This example is that given the equation is x plus 2 squared and equals negative 20 times parenthesis y minus 1. Okay. Alright. Now, we know this equation can be written as x minus negative 2. Negative negative is positive. And y minus 1. This basically tells us that the graph of this one is actually can be got by shifting this graph x squared equals negative 20 with 2 units to the left, because here is minus negative 2. Negative 2 means to the left. Minus 1, and then means 1 unit up. Okay. The reason I wrote in this way is because I know the vertex will be negative 2 and the x coordinate is negative 2, y coordinate is 1. I wrote in this way. Okay? Yeah, then you wrote in this way, you will tell that vertex is actually here. And the vertex, where the vertex is, it will basically tells you this graph can be gotten by shifting original one with negative 2 units, means 2 units to the left and 1 unit up. Yeah. So you write in this way, you know where the vertex is, and you also know that where you should shift the picture. That's an important step. Now, we know this equation well from the first 2 examples. Y without squared, so y needs to stand alone. Then both sides divided by negative 20. Okay. Then you will have a y equals negative 1 over 20 equals x squared. Now, y stands alone without squared means the open direction is either upward or downward. Anyway, the open direction is vertical. From this negative sign, it tells us the open direction is downward. Okay. Now, downstairs, 20 has to be equal to 4p. Always remember that. Okay. Then you solve for p, both sides divided by 4, p is 5. Once p is 5, then you know, basically, you will get what? For this function, basically you get this, the picture would be like that. Okay. You know the vertex is somewhere here. Okay. That's 0, 0. And then open direction, oh, this one doesn't work. Because of what? It's downward. So you got to see it's not this one. It's like that. And you have a P, so you know 1, 2, 3, 4, 5. And then you have a 0, 5. Okay? And you know the directories will be 1, 2, 3, 4, 5 will be there. That's basically for this one. Okay? Now is that the vertex is -2, 1. -2 is here, 1 is here, so you know the picture eventually shifted to here. In vertical direction, then you know is 1 unit. Okay, so the focus, it was here. Now you do is plus -2, 1. So -2, 1. -2 add on 0. So you then have this point will go here. And then -5 plus 1. So that's -4. So you know this point, focal point, will be somewhere here. Okay. And the vertex will be from origin 0, 0 goes to -2, 1. That's right here. And you shift the line, that's fine, to the left, but you know, the line goes 2 directions. It doesn't feel you actually shift in the horizontal way. But you do have a 1 unit up. So you should have eventually the line directrix is over there. So basically you do right here is plus -2, 1, -2 on 0, 1 on -5. So you get -2 is -2 plus 0 is -2, and 1 plus -5, you get -4. Yeah. Okay. Directrix, you just add is y. So then you 1 plus 5 is 6. Okay. So you add that, add this focal vertex on the focal points, and you will get the new one. And here's the same thing. Okay. Now